Okay, today we are going to look at the quadratic equation, which I have written here, and we are going to start the process of turning it into the quadratic formula. I'm going to go part way, and you're going to have the opportunity to finish. So the first thing we're going to do is, when we're setting up the quadratic formula, we're finding out what the x values are when the equation equals 0. So we'll just put and equals 0 out here because we want that function to equal 0. Okay, so if we're solving for x, we need to get all the x's on one side, everything else on the other side. So we're going to move the c over, and I want the coefficient in front of x squared to be a, so I'm going to divide everything by a and move the c over. And what we end up with is x squared plus b over a times x. You can put x in the numerator or behind if you want to, and that's going to equal c over a. Okay, now in completing the square, we need to add something here so that we can complete this square, which means we're going to have to add something over here. In order to do that, let's take a look at, okay, so here's the example I want to look at. Let's say x plus 3 squared, because remember we want to end up with a squared term. So x plus 3 squared is going to be x plus 3 times x plus 3. Okay, if we FOIL that out, it'll be x squared plus 3x plus 3x plus 9. Okay, how many 3x's do we have? We have 2 3x's. We have 1 and we have 2. So you'll notice we have a 3 up here and we have 2 3x's down here. And with this 3, we also have a 9 here. So if we group like terms, we have x squared plus, I'm going to say 2 times 3x plus 3 squared. It's really 6x plus 9, but if you will notice, the relationship that you have here is this term is twice, the middle term is twice what you have up here with the 3, and the other thing that you'll notice is what you're adding is the square of this term. So the question is, when we go to complete the square, how do we figure out what number we need to add here? What's the square of what needs to be here? But we all derive that because we have an x term if we go back to the original equation. So let's go back, and we have b over a x. So what this is going to end up being in a squared term is x plus, it has to be half of b over a, so it's b over 2a. And the reason it has to be half is when you multiply, when you FOIL out whatever this term is, we used the 3, it's twice the value. So this term here has to be half of what the 6 is here. Okay, so that's where the b over 2a goes. So what ends up here is b over 2a squared. I'm going to add that. So you have to add b over 2a squared. Now I've gone through this, and what I would like you to do is take the equation x plus b over 2a quantity squared is equal to, I forgot a negative sign up here earlier, negative c over a plus b over 2a quantity squared. I'd like you to take that equation. I will put a red box around it, really a dark red, haven't used this one before. I want you to take this equation. I want you to start up here with f of x is equal to ax squared plus bx plus c, set it equal to 0, copy the work that I did to get down to this equation in red, And I want you to take that, solve for x. And the easy thing to do, because you've got this squared term up here, take the square root of each side and then solve for x. But this craziness over here, before you take the square root, you probably want to do PEMDAS, get rid of the parentheses, deal with the exponents, get a common denominator, and deal with that. And there's a short form to fill out associated with this video. Go ahead and watch the video, take some notes, fill out the form, and in class what I want you to deliver is a sheet that starts with f of x is equal to ax squared plus bx plus c, and then I want you to end up with x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Made with Doodlecast Pro.